In this video, I'm going to go over the margin of error and how it can be used to calculate the sample size when we wanted to determine a precise range. So remember that there's a trade-off between certainty and precision. The more confident we want to be, the larger our z-value is going to be, and so our range is going to be larger. If we want to be more precise, that is, have a smaller interval or a smaller margin of error, we need a larger sample size. And so we can determine that sample size a priori, that is, beforehand, if we know what we want our margin of error to be. Suppose that we know that the true proportion of ISU students who never drink alcohol is actually 25.1%. We want to create a 95% confidence interval for a sample, and we want our margin of error to be exactly 1, so that we reach up and down exactly 1. Remember that our margin of error is defined as the critical z times our standard error. So we know what the standard error, it's just the square root of the probability of success, which is our proportion, times the probability of failure, that is, drinking alcohol, the proportion who drinks alcohol. This is determined as 1 minus 0.251. So that's how I found this number. We then divide that by our sample size, and this whole term is square rooted. Our critical z is 1.96, and that's because we want to create a 95% confidence interval. So that is from the critical z's I gave you in earlier videos. The margin of error is also given to us because we know we want to create a confidence interval such that we sample so the margin of error is 1% or 0.01. So now we have this crazy equation, and we have one variable, the sample size, that we need to solve for. So we need to rewrite this whole equation in terms of n, because that's our sample size. The first thing I can do is move this 0.01 to the right-hand side. That's just dividing by. And then I can move the square root of n to the left-hand side, because multiplication and division you can remove from underneath the square root sign, so you can separate them out. Remember, it's just addition and subtraction that you have to keep underneath the square root. The next step then is just to find n by itself, and you can do that by just squaring this whole term. So once we've squared that whole term, we can just calculate this out, and that's going to be 7,222. So we need to sample 7,222 people to get exactly a margin of error of 1%. That is, we reach up 1% and we reach down 1%. So the full range of the confidence interval will actually be 2%. The other thing I want to note here, these steps that I'm moving between are just simple arithmetic and solving for n by itself. So I'm not doing anything fancy other than basic arithmetic. And now that we know how to construct confidence intervals, the next step is to learn how to run hypothesis tests using them.